Hi everyone, we're going to sketch the graph of this polynomial f of x and fill out some information first. First we're going to determine the degree in, and that's, since this is not in standard form, we have x to the first power, and if you expanded that, that would be x squared. So just add those two numbers up, the multiplicities, and so n equals 3. Our lead coefficient is positive here, so we have an odd number here, and our lead coefficient is positive. We'll talk about this in just a minute, but we just need to remember that. Our y-intercept is when x is 0. So we have f of 0 equals 0 times 6 squared, which equals 0. So our y-intercept is 0, 0. Our zeros are when y is 0. That's your x-intercepts. So you have a 0 here, and negative 6 plus 6 is 0. So we have 0, 0 with multiplicity of 1 and negative 6, comma 0 multiplicity of 2. That just means that when we graph this, we can cross the x-axis when it's an odd number, and we only can touch it if it's an even number. Our maximum turning points are n minus 1. Our n is 3, so 3 minus 1 equals 2. And we also, after we graph this, we're going to determine where our graph falls below y, where our y is negative and where our y is positive. We'll talk about this also later. So now we're going to go back to n behavior. So we need to know that our n is an odd number and our lead coefficient is positive. So if our n, our degree is 3, which is odd, and we have a positive lead coefficient, so that means we're in this area here. So this is your n behavior right in there. And all that means is this, that when we graph this, and I'll kind of graph it here, so something like that, what we're looking at is the n behavior. We're looking at that piece and this piece. So when we're graphing from left to right, we're starting in quadrant 3, we're ending in quadrant 1. So we know in quadrant 3 it's negative, negative. Quadrant 1, we have positive, positive for x and y. And that just means when x from 0 gets larger and larger, our y also gets larger and larger. That puts us in quadrant 1. All right. And when x from 0 gets smaller and smaller, so does our y. And that puts us in quadrant 3. All right. So we already know, let's graph this. And we're not going to worry about min and max on this video. So when we graph this, we know we're going to start graphing from left to right, start in quadrant 3 and end somewhere in quadrant 1. Now let's plot our x and y intercept. So we have 0, 0 here, and our x-intercept is 6. 1, 2, 3, 4, 5, 6, negative 6. And if you want, you could plug in negative 3 and see where our max would be, but we're not going to worry about min and max on this video. So this is how it goes. Let's erase this. So we're starting here, we're going to negative 6. Starting in quadrant 3. Now at negative 6, we have an even multiplicity. That means I can't cross, I only can touch. So kind of make a U-turn. And again, at negative 3, that would be 9 times negative. It would be way down here at negative 27. So it kind of comes down way down here. But we're not worrying about our min and max values right now. We're just sketching a general idea of what the shape looks like. So once we get to 0, which is this part, our multiplicity is an odd number. That means I can cross. So there is our graph. Now we're going to look at where the graph is positive and negative. So we're looking at y equals 0. So above the graph, that's where y is greater than 0. And below the graph, there is where y is less than 0. So instead of y, we'll say f of x, where is f of x positive? And the only place it's positive is right through here. This one right here. So that is from 0 to infinity. You're looking at your x values. Now where is our graph? Negative. So where is f of x? Negative. That means falls below this. And that's this part of the curve of the graph. Whoa. So that's this part right in here. So that's going from negative infinity to 0. And that's it. Thank you. Have a nice day. Bye-bye.